Over the last few years, the world has been swept up in the hype of artificial intelligence and large language models. Headlines promise sentient chatbots, autonomous agents, and machines that reason, plan, and act. But beneath the marketing gloss, a quieter, more grounded truth is emerging. Most of what we call AI today is actually software engineering. Large language models feel magical, but at their core, they are still text in, text out statistical engines. Everything that makes them look intelligent comes from the layers of engineering wrapped around them. Strip away the branding, and a language model is fundamentally simple. You give it tokens. It predicts the next token. Then it repeats. Under the hood, those tokens are just vectors of numbers, in and out. There's no memory, no goals, no tools, no world model, just a massive pattern matching engine trained on text. On its own, a raw model is impressive, but limited. It can chat, write, and code, but it can't fetch data, run commands, browse the web, or take action in the real world. To turn a predictive text model into an assistant, or an agent, we surround it with infrastructure. First, Retrieval Augmented Generation, RAG. It gives the model access to external knowledge, so it doesn't rely on stale training data. Documents are parsed, chunked, embedded, and stored in a vector database, then retrieved and assembled into context. Indexing, caching, freshness, syncing. All of it, engineering. Next, tool calling. This is what gives the model hands. It can trigger APIs, run code, search the web, or manipulate files. That means function schemas, validation, routing, sandboxing, error handling, and observability. Then, agentic workflows. Planning breaks a task into subgoals. Memory tracks what happened, and a loop lets the model act, observe, and correct itself. Task planners, state machines, goal tracking, more engineering, wrapped around the same predictive core. And there's still more. Guardrails to keep outputs safe, orchestration to coordinate everything, and protocols like MCP to connect it all. None of this is AI in the science fiction sense. It is engineering, clever, complex, essential engineering. Now combine them, a predictive engine, with retrieval, with tools, with planning, with memory, with guardrails, and a polished interface. Suddenly, it feels like a general-purpose AI. But the intelligence isn't in any single model. It emerges from the system as a whole. The model is the brainstem. The engineering is the cortex. And here's the twist: these models are now good enough at coding to help build the very scaffolding that surrounds them. Models write code. Engineers refine it. The system looks smarter. That attracts investment. And the models help build the next layer. A recursive, self-reinforcing loop. A snake coding its own tail. So we are not on the brink of artificial general intelligence. We are building increasingly sophisticated software systems, powered by predictive models. We are not building artificial minds. We are building artificial systems. And the language model is just one component. And honestly, that is far more interesting than the science fiction version.